Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at geometric series. So remember that a series is just the sum of terms in a sequence. So for a geometric series, we use this formula here. Sn has the same meaning as it did for arithmetic sequences. It is the sum of the first n terms. A is the first term, R is the common ratio. So let's use this formula to calculate the sum of the first 20 terms of this series here. So we're looking to calculate S20, that means N is 20. So A is the first term, just 1. R is equal to this divided by this or this divided by this. R is equal to 0.9. That's what we're multiplying by each time. Timesing by 0.9 each time. Again, if you don't know what R is, just take any term and divide by the previous term. So it's 0.9 to the power of n minus 1, all divided by R minus 1. So putting that on our calculator, we get about 8.65. We would expect that our answer would be a decimal because each of these terms each time is having one more decimal place. All right, let's now look at a harder question. So the sum of the first three terms of a GP, which means geometric progression or geometric sequence, is 21. The sum of the next three terms is 168. We're going to calculate A and R. So what we're going to do here is set up two equations. Hopefully whenever you are asked to find two quantities, your first thought is simultaneous equations. Now the sum of the first three terms, we can use the formula on the previous slide, or we can just go A plus AR squared. That's true for any GP. So we're told that that is equal to 21. The next three terms will be AR cubed plus AR to the power of 4 plus AR to the power of 5. And we are told that that is equal to 168. So how are we going to solve this for A and R? Well, what we can do is we can make these a little easier to work with by taking out a common factor. So in this equation here, each term has a common factor of A. So I'll put that out the front. I get 1 plus R squared, and that's equal to 21. Now, if I do the same here, the common factor is AR cubed. So if I have AR cubed out the front, I times by 1 to get that term, I times by R to get the second, and R squared to get the third. All right, so this is starting to look good because we had the same brackets in both cases. So what I can do is eliminate these brackets by dividing. I'm going to divide this equation by this equation. So AR cubed divided by A just gives me R cubed. And if I divide this bracket by this bracket, it just disappears. Now 168 divided 21 is equal to 8. So I've just got R cubed is equal to 8, R is equal to 2. So just note, when you have an odd power, there is only one solution to this kind of equation. So I found that R is equal to 2. What will be A? Well, let's substitute back into this equation and we'll find A. So A times 1 plus R squared is equal to 21. This, however, is just 7. So A is just 21 divided by 7, which is 3, and we're done. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.